Hello everyone. Today we are going to discuss Nernst equation. Nernst equation was developed by German chemist Hermann Nernst. He also discovered third law of thermodynamics, and that's why he was been awarded with Nobel Prize in 1920. Nernst equation connects three data: electrode potential of the cell, Gibbs free energy of the reactions, and the equilibrium constant of the reaction. When a chemical reaction takes place in electrochemical cell, we can find out electrode potential. Now this reaction also having a Gibbs free energy value. So electrode potential is connected with the Gibbs free energy, and since the reaction is taking place in the electrochemical cells, so it also having some concentration data which can be denoted by equilibrium constant K. So now all these three data can be connected and then we can derive equation, Nernst equation. Now, what is the relationship between the Gibbs free energy and the equilibrium constant? So this is the equation delta G0 equal to minus RT ln K. So K is the equilibrium constant, R is a constant, T is the temperature which is expressed in Kelvin. Relationship between Gibbs free energy and electrode potential is delta G equal to minus NFE cell. Now when we are talking about in standard condition, the equation will be delta G0 equal to minus NFE0. So delta G0 indicates that all reactants and products are in the standard state, and E0 is the standard potential. So standard states means we are talking about when the condition is 1 atmospheric pressure, 25 degrees Celsius temperature means 298 Kelvin. Now both the equation number 1 and equation number 2, you have seen this equation has a negative sign. So negative sign indicates that reaction is spontaneous. Make the equation 1 equal to equation 2 means NFE0 equal to RT ln K. So from this equation we can rearrange and we can get this equation E0 equal to RT by NF ln K. Now N is the number of electrons which is transferred in the reaction, and F is the Faraday constant, that is 96,500 coulomb per mole, and E0 is the standard potential. Now how to find out the N? Here I have taken one example. Like this is the reaction is taking place. Aluminium plus copper plus 2, it's give you aluminium plus 3 plus copper. Now from this reaction we have to find out the two half reaction, means one is the oxidation reaction, another one is the reduction reaction. So now this is the oxidation, in aluminium oxidized to aluminium 3 plus 3 electron, and copper plus 2 undergo reduction, so copper plus 2 accept 2 electrons, it give you copper. Now if you look at the two reactions, here you can find out your number of electrons for one of the half reaction is 3 and another half reaction is 2. So now we have to make it equal number of electrons. So that I have to multiply this equation into 2 and this equation with 3. Then finally we are getting 6 electron. So this is our net reaction. So in this particular reaction 6 electrons take part in the reaction, so that's why N will be 6. This equation is delta G equal to delta G0 plus RT ln K. So here delta G is the Gibbs free energy of the reaction, delta G0 is the Gibbs free energy in the standard condition, R is a constant, T is a temperature in Kelvin, K is a equilibrium constant. Now we know that delta G equal to minus NFE and delta G0 equal to minus NFE0. Now we can put this value in this equation. So if we put these values in this equation, we are getting this equation. Then we can rearrange the equation in this way: E equal to E0 minus RT by NF ln K. Now we have to convert ln into log. So we have to multiply with 2.303. So then we are getting this equation. This is the equation number 3. Now R is a constant, the value is 8.314 joule per Kelvin mole, and T is 298 Kelvin, and F 96,500 coulomb per mole. So if we put all these values here, then we are getting is E equal to E0, 0.0591 divided by N log K. So equation number 3 and equation number 4 is the Nernst equation. So the Nernst equation measures electrochemical cell potential at any temperature, pressure and concentration. Then this equation is E equal to E0 minus 2.303 RT by NF log K. So here T you can put any temperature. But if you want to calculate the Nernst equation at 298 Kelvin, then this entire part can be converted into this value 0.0591 divided by N log K. So E0 cell is the cell potential at the standard state, 1 atmospheric pressure and 1 molar concentration, 298 Kelvin. And E cell is this one. E cell is the cell potential of a non-standard state, which means that it is not measured under a concentration of 1 molar and pressure of 1 atmosphere. How we can measure E0 value? So this is the equation we can measure E0 value of the cell. E0 cell equal to E0 cathode minus E0 anode. We know oxidation takes place in anode and reduction takes place in cathode in electrochemical cell. So from there we can find out the E0 cathode and E0 anode. Then if we put this value, we can get the electrode potential of the cell at standard condition. Now if we connect Gibbs free energy, electrode potential and equilibrium constant, we will get a triangle like this. So here in this point, if we denote it's a equilibrium constant and this point denotes Gibbs free energy, then equilibrium constant and Gibbs free energy is connected via this equation, delta G0 equal to minus RT ln K. Now E0 is at this point, so now delta G0 and E0 is connected via this equation, delta G0 equal to minus NF E0. Now E0 and K is connected again via this equation, E0 equal to 0.0591 divided by N log K. Now let's see what happened in the Nernst equation at equilibrium. Now at equilibrium, delta G equal to 0. So if delta G equal to 0, then delta G equal to minus NFE, that also 0. So now from this equation, we can see that E is also 0. Now this is Nernst equation. So in this Nernst equation, we can put E equal to 0 because at equilibrium, delta G equal to 0. So E equal to 0. So we can put E equal to 0 in the above equation. So now if we rearrange the equation, Nernst equation at equilibrium, we get this equation log K equal to E0 into N divided by 0.0591. Thank you for watching this video. If you find this video is helpful for your study, share and subscribe my channel Chemistry Affinity. If you have any queries related to chemistry, you can contact me chemistry.affinity@gmail.com. Thank you.